All right, hydrogen nucleophiles. In this case, we're looking at hydrides. Remember from way back when we first talked about alcohols and ethers and that sort of thing, H minus, as found in something like potassium hydride, is an exceptionally strong base, not a nucleophile. We remember that if we wanted to use a hydride as a nucleophile, we needed to kind of tone it down a little bit by using Lewis acids. And so we end up with sodium borohydride or lithium aluminum hydride as our main sources of H minus as a nucleophile. And we see with treating an aldehyde or ketone with either of these, we'll reduce it to the alcohol. With ketones, you'll end up with a racemic mixture. With aldehydes, you will end up with a primary alcohol, so it's not chiral. With these, we need to remember that the sodium borohydride is the mild version. So if you can use it, use it. You want to use the lithium aluminum hydride only if you really need it. So this will only reduce aldehydes and ketones. We're going to see that the lithium aluminum hydride, which is stronger, will also reduce esters, acids, acid halides, and amides. So we have to be very careful of other things present in our molecule. So while we have not covered yet acids, esters, acid chlorides, amides, which that's next chapter, so we will cover them soon, be careful about using lithium aluminum hydride in the presence of those because you will reduce those as well. If you want to reduce everything, that's fine. However, if you only want to reduce your aldehyde or ketone, you'll want to use the borohydride. You can reduce an aldehyde in the presence of a ketone, if you're lucky, by using stoichiometric equivalence, as long as you're using a fairly concentrated solution of your aldehyde with the ketone. Although you will still probably end up with some of your molecules with the ketone reduced. Generally speaking, a little bit hard that way. So what you can do instead is you can protect it with various groups, right? You can protect an aldehyde with your acetal. Then you can protect your ketone with a thioketal. Use acid and water to cleave off your acetal, remaking your aldehyde, and then you can reduce it. And then you can regenerate your sulfur-protected ketone by using the mercury 2. So, lots of words I just said, right? That's the whole point of OChem, right? Is you think you know everything, and there's always these very subtle rules that we have to consider. So, with hydrogen nucleophiles, very simple section. They will reduce your aldehyde or ketone. The borohydride is milder and will only reduce aldehydes and ketones with a preference for aldehydes. Lithium aluminum hydride is a much stronger reducing agent and will also reduce all other carbonyl containing compounds, even amides. So all the way down there. So just be wise in your choices because you may have to worry about other functional groups. All right. Lastly, the sodium borohydride can be used in the presence of protic solvents or protons. The lithium aluminum hydride, you can't have protons there because it will simply act as a base and you'll end up deprotonating your alcohol or whatever might be acidic within your compound. So that's it for hydrogen. Our last nucleophile will be carbon, for which we will have 2 videos.